So far, we discussed about atoms. Now, today we will look at molecules. Now, what is a molecule? Molecule is an electrically neutral group of two or more atoms chemically bonded together. That means when two or more atoms chemically combine together, chemically bond together, after their combination, whatever group they formed, that electrically neutral group is nothing but known as molecule. So combination of atoms is termed as molecules. Now, the molecule that is formed, there are atoms combining, and those atoms are holding together because of the forces. The forces hold the atoms together in a molecule, and those forces are called as covalent bonds. So you can say the combination of atom is a molecule. Now we know that atoms of most of the elements are very reactive and they cannot exist in the free state. They cannot exist as single atoms, right? But this is not the case with the molecules. The smallest particle of a compound which is able to exist independently. It means atom may or may not exist independently, but molecules can exist independently. So molecules can exist in free state because molecules are very stable. So you can have the another definition for a molecule. It's like smallest particle of a substance which has the properties of that substance and can exist in the free state. So molecules basically are the smallest particles of compounds, smallest particles of substances, and they are having the properties of the substance, and they can exist independently. Okay. If we look at some molecules, say for instance, we are having some diatomic molecules. That means where two atoms are combining. For instance, in oxygen, two atoms of oxygen combine and they form oxygen molecule. This O2 is nothing but the molecule of oxygen, where two atoms have been combined. Same, three molecules of oxygen combine, they form ozone. So here three atoms have combined and formed a molecule of oxygen. This is again a molecule of this is a molecule of ozone, and this is a molecule of oxygen. Here two atoms have combined and here three atoms have been combined. This is known as diatomic and triatomic molecules. Now, based on the number of atoms combined to form a molecule, we are having atomicity. Atomicity is nothing but the number of atoms in a molecule of an compound. That means whatever number of atoms have combined to form molecule, that number of atoms is termed as atomicity. Now see, we are having monoatomic molecules, we are having diatomic, we are having triatomic, we are having polyatomic. Now monoatomic means when two atoms combine to form one molecule. So if you look at helium, neon, argon, these are single atoms. Even they exist independently. You can also say these are elements. You can in fact say these are atoms. So basically, in noble gases, in monoatomic, there only one atom is present. So here we are having only one atom of helium. This is one atom of neon, and this is one atom of carbon. So these are termed as these are termed as monoatomic. So monoatomic means just that the number of atoms in their molecule is only one. Okay. In fact, if you look at the metals like sodium metal, magnesium metal, aluminum metal, there also you can see the atomicity. There is one. That means only one atom is present. If you look at sodium, that is Na. It means one atom of sodium is present in the molecule. Okay. So the atomicity here is one. That is why they are called monoatomic. Mono means one. Diatomic. Diatomic means where two atoms have combined to form a molecule. Like in case of oxygen, two atoms of oxygen combine to form oxygen molecule. Two atoms of chlorine combine to form chlorine molecule. Two atoms of fluorine combine to form fluorine molecule. So that means here in one molecule, two atoms have been combined. So that is why it's known as diatomic. If you look at triatomic, the word tri, that means three. Definitely there are three atoms combined to form a molecule, and here we can have O3. O3 is nothing but ozone, and it exists in the form of O3 molecules. So that means 3 oxygen atoms combine together to form ozone gas. Now, polyatomic means in which many number of atoms have combined. So we are having phosphorus. That means 4 atoms of phosphorus have combined to form phosphorus molecule. 8 atoms of sulfur have joined together, have combined to form sulfur molecule. So in sulfur molecule there are 8 atoms, and in phosphorus molecule there are 4 atoms present, and these are known as polyatomic. That means many number of atoms have been combined to form their molecules. Clear? Now, when atoms of different elements combine together in definite proportion, they form compound. So basically compound is nothing but the compound is the combination of molecules, because in a molecule we are having atoms of different elements combined together. So basically, just like element contain atoms, same compounds contain molecules, and molecules in turn contain atoms, or you can say elements. So basically compound is formed of molecules. So when when atoms of different elements combine, they form compounds. They form basically molecules, and molecules form compounds. Clear? So just like we are having elements, we are having compounds. And when element and element combine, for instance, when hydrogen element and suppose oxygen element combined, they form water, and water is nothing but a compound. When elements combine, they form compounds. Similarly, when atoms combine, they form molecule. It's similar to that. When elements combine, they form compounds. See, carbon element is combined to the oxygen element. Here carbon is a kind of an element, and oxygen here again is a kind of an element here. But here we are having 2 atoms of oxygen. That means 2 atoms of oxygen have been combined, and we know whenever 2 atoms combine, whenever 2 or more atoms come, they form molecule. Basically it's a molecule, one molecule of oxygen. So they combine together and form carbon dioxide. And here again you can see they combine in definite proportions. So if you look at the proportion of this by volume, 1 atom of carbon combines with the 2 atoms of oxygen. That means by volume, its volume proportion is 1:2. And by mass, if you look at the mass ratio of the carbon and oxygen, it's 3:8. Molecular formula or the chemical formula. Now, a chemical formula is nothing but it represents the composition of a molecule of the substance in terms of the symbols of the elements present in the molecule. And it means whatever be the composition of a substance, whatever be the molecules of a substance, chemical formula represents those composition, and it represents them in terms of the symbols of the elements. That means we have to represent the elements with the help of symbols, which we learned in the previous lecture. Molecular formula is also known as chemical formula. Okay, so the formula can be of an element, or the formula can be of a compound. Now let's see the formula of elements. It is the statement of the composition of its molecule, in which symbol tells us the element, and the subscript, that is the lower figure, will tell us how many atoms are present in one molecule. So that means whenever we are writing the formula of elements, we have to write the composition of the molecule, but in terms of symbols. We have to write the symbols for elements, and also we have to write how many atoms are present in that one particular molecule, and that number has to be written in the subscript, that means in the lower figure. Let's try to understand it by an example. Suppose we are having one molecule of hydrogen element. So hydrogen is an element, and we are having its one molecule. So we know that one molecule of hydrogen element contains 2 atoms of hydrogen. That means the formula will be the element, first the symbol for element, that is H. Then we have to write in the lower figure, in the subscript, the number of atoms. And we know that in one molecule of hydrogen there are 2 atoms. So we have written 2 in the lower figure. So this 2 represents one molecule of element hydrogen contains 2 atoms of hydrogen. If we write 2 here in front of H, if we write 2H, that means 2 separate atoms of hydrogen. H2 means 2 atoms of hydrogen have been combined. But if we are writing 2 times H, that means 2 separate atoms of hydrogens have combined. So these are two different things. Yeah, but if we write 2H2, we will keep H2 as it and we will write 2 in front of it, then it will represent 2 molecules of hydrogen. Here it's representing 1 molecule of hydrogen in which 2 atoms have been combined. But if we write 2H2, that means 2 molecules of hydrogens. Okay. Similarly, if we look at the formula of elements for sulfur, we know that for 1 molecule of sulfur, 8 atoms of sulfur combined. Okay. For 4 atoms of phosphorus combined to form 1 molecule of phosphorus. And here 2 atoms of chlorine have combined to form 1 molecule of chlorine. And for inert gases like helium, neon, argon, as we know, they are monoatomic, only one atom is there. So their symbols and their formula, that's their symbol is He, their symbol for neon, that is Ne, their symbol and formula is just the same. Ne is their symbol, Ne is the symbol of neon, and Ne is also the formula for neon. Okay, and same goes for the metals also. Now these formulas were of elements where same atoms have been combined. Now let's look at the formula of compounds, because we know that formula can be of an element or a compound. Now what do we mean by formula of compounds? That means where atoms of different elements have been combined. Again, it is a statement of the composition in which the chemical symbols tell us which elements are present, and the subscript tells us how many atoms of each element are present in one molecule of the compound. Again, the same thing, we have to look the elements which are present in the compound and we have to write down the symbols for them, and then we have to look at how many atoms of each element are present, and that number should be written in the subscript. Let's look at the examples. We are having a compound, that is water. Water is a compound here, and water molecule, we are having here water molecule because molecule is present in compound. Compound is actually formed of molecules. So basically water compound contains millions of molecules of H2O. Okay, now let's look at the molecule H2O. You can see here it contains 2 atoms of hydrogen and 1 atom of oxygen. So first we will write the symbol for hydrogen and oxygen, that is H and O. Then we will write the number of atoms. Now how many hydrogen combined, how many hydrogen atoms combined? 2. So we have written the lower figure as 2. So it means 2 atoms of hydrogen have combined with 1 atom of oxygen to form the molecule of water. Okay, so this is the formula of water. So here H2 represents 2 atoms of hydrogen, 2 atoms, not molecule, 2 atoms of hydrogen, and O represents 1 atom of oxygen. Okay, now if we write 2 in front of H, that means 2H2O. If we write like this, then it means 2 molecules of water. If here it is not, here there is nothing written here in front of H, that means it's 1 molecule of H2O. But if we write there 10, that means these are 10 molecules of H2O. Okay, so whatever figure we are multiplying in front, that is that figure 2. So for instance, that multiplies the whole formula of H2O, not for just one element. Okay, so that means if we write 2, that means 2H2O. And definitely if 1 molecule of hydrogen contains, 1 molecule of water contains 2 atoms of hydrogen, then 2 molecules of water will contain 4 atoms of hydrogen, right? If 1 molecule of water contains 1 atom of oxygen, then 2 molecules of water will contain 2 atoms of oxygen, right? So this is how we write the chemical formulas. If we look at carbon dioxide, first of all, let's write the elements. So elements, there are carbon and oxygen. Then we have to write the number of atoms present. So carbon is 1 atom, oxygen is 2 atoms. So 1 atom of carbon and 2 atoms of oxygen combined to form a molecule of carbon dioxide. Same goes for ammonia, NH3. 1 atom of nitrogen combines with the 3 atoms of hydrogen to form a molecule of ammonia. So these are 1 molecules here. 1 atom of hydrogen combines with 1 atom of chlorine and forms a hydrogen chloride. This is all about the molecular formula. Now let's look at the molecular mass. Like just as an atom has atomic mass, in the same way molecule has a molecular mass. And the molecular mass is same as the atomic mass. That is the mass of a substance is the molecular mass of substance is the relative mass of its molecule as compared to the mass of a carbon 12 atom that taken as 12 units. As we know, carbon 12 has been assigned the mass of 12 units, and we have to find the relative mass by relating the masses of molecular masses of molecules with the carbon 12 atom. Okay, so that means whenever you are relating, molecular mass will indicate the number of times one molecule of substance is heavier than 1/12 of a carbon 12 atom. Say for instance, if we are having hydrogen and the molecular mass of hydrogen is 2 units, so that means molecule of hydrogen is 2 times heavier than 1/12 of the carbon 12 atom. So that is molecular mass, and it's again written in units. It's expressed in atomic mass units. Now let's calculate the molecular mass of some compounds. Now see, if the molecular formula of substance is known, then you can easily calculate the molecular mass. So that means you should know the molecular formula for substances. So molecular mass is nothing but it is equal to the sum of atomic masses of all the atoms. Sum of atomic masses of all the atoms present in one particular molecule. So for instance, if we are taking molecule of water, and we need to find the molecular mass of water, that means we have to sum its atomic masses. Now see, it contains hydrogen or oxygen, that means we have to sum the atomic mass of hydrogen and the atomic mass of oxygen. So let's first look at the atomic masses of both. Now see, mass of one hydrogen atom is 1 unit, but here we are having two atoms of hydrogen, so mass of two hydrogen atoms is 2 into 1, that is 2 units. Now, mass of one oxygen atom, that is 16 units. We are having only one oxygen atom here. So now molecular mass is equal to atomic masses of sum of atomic masses of both the elements. So mass of two hydrogen atoms and plus mass of oxygen atom. Now what is the mass of two hydrogen atoms? That is 2 units. And what is the mass of oxygen atom? That is 16 units. 2 plus 16, it will give you 18 units. That means the molecular mass of water molecule is 18 units. Now let's calculate the molecular mass of sulfuric acid, hydrogen sulfate, H2SO4. Again, the molecular mass is equal to sum of atomic masses of the elements. So, which element is present in sulfuric acid? That's hydrogen, sulfur, and oxygen. So, we have to sum their atomic masses. So, mass of two atoms of hydrogen, okay? 2H here is two atoms of hydrogen. Mass of here sulfur is only one atom, so mass of sulfur atom, and oxygen are 4 atoms, so mass of 4 oxygen atoms. Now mass of one hydrogen atom is 1, but we are having 2 hydrogen atoms, so into 2, plus mass of sulfur atom, that is 32, and mass of oxygen atom is 16, but we are having 4 atoms, into 4. So you will get 98 units. That means the molecular mass of sulfuric acid is 98 units. This is the molecular mass of a molecule of sulfuric acid. So this is how we can calculate the molecular masses. But we should know the formula of a compound. Then we can calculate the molecular masses. Formula of the compound is mass, and the atomic masses of the elements is mass. So whenever we know the molecular formula and we know the atomic masses of elements, we can calculate the molecular mass.